Thanks for watching. If you enjoyed this video, please hit the subscribe button and ring the notification bell so you never miss an update. Leave a comment below to help grow the channel, and don't forget to smash the like button. All right, lecture 4, multiplication. So, last lecture we talked about multiplication facts and some patterns. One thing I failed to mention, however, is exactly what multiplication is. And so multiplication, quite simply, is just repeated addition. So what does that mean? Well, one of the things we learned how to do in the last lecture was easily double numbers, like 24, for example. The double of 24 is?
48.
Good, 48. So what does that mean? 24 times 2. Well, it means that 24 is added to itself twice. 24 plus 24. 4 plus 4 is 8. This is all from lecture 2. 2 plus 2 is 4. 48. And we've confirmed it or checked it. So this, however, might not be so easy to do with, say, 24 times 5, which is?
120.
Good, 120. Because we don't want to add 24 plus 24 plus 24 plus 24 plus 24. It gets to be a little bit of a pain, yes? So for that reason, in general, we want to adopt a paper and pen method, or a long form method of doing multiplication. That's what we're going to talk about today. And let's actually just use the example we just did, 24 times 2. So the first thing we'll do is we will write it in a vertical fashion, like we did with long form addition. With the time signal replacing the plus or minus symbol that we used in long form addition and subtraction. Now, you notice that I've lined the place values up like I would if I was doing addition. However, it doesn't actually matter. You could have written it as 2 times 24, or 24 times 2. None of this makes any real difference. However, I'm going to suggest always aligning it, well, we'll call it right justified. If you've ever used a word processing program, you're probably familiar with that term, right justified. It means everything is pushed off to the right as far as it can go. And by doing that, we'll devise a strategy that allows us to keep our place throughout the many steps of the multiplication process. So let me just erase this. Now that we have our factors arranged in vertical columns, what do we do next? Well, the bottommost row, right? See here we've got 2 rows, and we're really only going to be talking about multiplying with 2 numbers, okay? If we were going to do more than 2 numbers, we'd probably want to do it in steps, okay? The bottom row will always be where we get our working digit from. Now, there's only 1 digit here, so we're only going to have 1 working digit in this problem. And so this is where we're going to be operating from. That's 2 ones. And we're going to multiply it by every digit in the number above, okay? And we're going to do it from right to left. So pen and paper math, always right to left. And we'll start with the 4. And 4 times 2, if we remember our multiplication facts, is 8. Now that we've done that, I'm just going to circle this so we can see what it is that we did there. Now that we've done that, I want to multiply this 2 times these 2 tens. So it'll be this part right here. And 2 times 2 is 4, and so I write it just like that. It's pretty straightforward, yes?
Yes.
Okay. Let's try a slightly more difficult problem that has a bit of a complication. Let's do 13 times 7. So we set it up vertically as we did before, and we'll start in the bottom row, of course, and with the 7. And so we'll first multiply 7 times 3, and what do we get when we multiply 7 times 3?
21.
21, that's correct. Now, we only have space in our answer section down here for 1 digit. Remember the funny money rule, right? We're not allowed to hold more than 9 of any denomination. So we're not allowed to have more than the number 9 down here. 21 needs 2 digits, yes? So we're going to do something very similar to what we did in addition, where we had a carry. We're going to carry the tens place of 21, that's the 2, over here. And we're going to write the ones place portion of the answer right here beneath the 7, okay? The 2, however, I'm going to write up here, I'm going to write it kind of small. A little bit like what we did when we carried or borrowed in subtraction. Now we do 7 times 1. And 7 times 1 is easy. It's just 7. But what do we do with the 2? Well, we have to add the 2 to the 7 to get 9. And so now we've arrived at our answer, 91. And we could check this by adding 13 up 7 times. And feel free to do that at home if you wish. I'm not going to do it here. There's not enough room on the board, I think. Now it's your turn to try one. There, that looks a little better. 64 times 8. So go ahead and pause the video and try that at home. Okay, so I already have the factors arranged by column. And I didn't mention this before. It's not necessary to put the biggest number on top, but I recommend it. It makes it a little bit easier going through the procedure. Always put the largest number at the very top. But we'll start with the 8 times 4. 8 times 4 is 32. We'll write down the 2 from the ones place right below the 8 here. We'll carry the 3 from 32 above the 6 like this. Next we have to do 8 times 6. Who remembers the 8 times 6 multiplication fact? Who wants to speak?
51.
No.
48.
48, correct. So 48, but we have to add to 48 3. So over here, I'm going to write down 48 plus 3. That's something we have to do before we write down our answer in the answer section. And 48 plus 3 is, of course, 51. I think that's what you were jumping the gun, weren't you? Yeah, okay. Now, what do we do? There's nothing to carry the 5 over from 51 to, right? So when it's the last digit like this, just like we had with addition, we'll just write both digits side by side like this, 51. And that gives us an answer of 512. Okay, that wasn't too bad. But now let's try something a little more challenging and do a 2-digit number times another 2-digit number. (56 times 19). So again, we line everything up vertically as we did before, and we're going to start with the 9 because, like I said, pen and paper arithmetic is usually done right to left. And so we're going to start on the right with the 9. And we'll proceed just as before. So we get 9 times 6. Remember in our multiplication facts, that's 54. We'll carry the 5 over here. Now we do 9 times 5 to get 45. And we have to add 5 to that to give us 50. Since it's the last digit in the upper row, we'll just write the full 50 down right here like this. Now I just want to point out at this point that it's important to write neatly in the answer section, because what we're going to do next is we're going to have to put another answer section below that and line it up. And if we get it misaligned, then it's going to affect our answer. So we finished with the 9. We've multiplied it by everything in the row above. So we now move over to the left to the next digit, which is a 1. Now, if I were just to do 1 times 6 and write the 6 underneath the 4 here, that would not give us the right answer. It's not even remotely correct, because I want to point out on this line, what this line has is the answer to the problem, 56 times 9. The next line should have the answer 10 times 9.
This should read 56 times 10. Sorry about that.
9. And not 1 times 9. So what we have to do is we will add a 0 right here, because we're not working in the ones place, because we're multiplying everything in the top row by 110, okay? So that's the reason for the 0 here. Another way you can think of it is each digit that you're working with, we'll call it the working digit, the answers that you write down will be written from right to left, and it will be directly underneath it. So we'll be directly underneath the 1, which is right here, and everything to the right should be zeros. So now we do 1 times 6 to get 6. We do 1 times 5 to get 5. And I just want to point out at this point, it might be a good idea after working with carries over here to strike them out after you've used them. That way you don't get confused in larger problems and accidentally add the wrong carry to the wrong place. So that's usually a good idea. So what do we do now? We have two answers. Which one is it, right? Well, if we think about what the rows actually mean, the first row is 56 times 9, and the second row is 10 times 9. What we're interested in is 56 times 19. That's the sum of these two things, yes? So what we have to do is add these numbers. And that's the reason that I told you to be really careful in how you write them. So we'll put a little plus mark there, and then we can use what we learned in lecture 2 to add these two rows up. So 4 plus 0 is 4. 0 plus 6 is 6. And 5 plus 5 is, of course, 10. And we get our final answer of 1,064. Let's let you try one now. Try the problem 705 times 87. Go ahead and pause the video and return when you have your answer. Okay, so a little more complicated because we have a 3-digit number up above and just a 2-digit number down below. But we'll work it the same as before. We'll start with the 7 in the lower right-hand corner. 7 times 5 is 35. We'll carry the 3. Now what do we do here? 7 times 0. What is 7 times 0?
7.
Ah, good. You made the very common mistake that people make. 7 times 0 is not 7. 7 plus 0 is 7, and that's what you're thinking. 7 times 0 is 0, because anything times 0 is 0. Okay? So 7 times 0 is 0, and then I have to add the 3 ones that I carried over from the 35 from before. And I'll just write that here, because 0 plus 3 is 3. Now I'm going to strike through the 3 so I remember that I've used it. And we move on to the next digit. Now we're at this 7, in the hundreds place. 7 times 7 is 49. I'll just write 49 right there. Now we move on to the 8, because we've multiplied the 7 times everything up above, but this is, of course, 8 tens, so I need to remember to put a 0 here in the ones place, because I'm going to start in the tens place. 8 times 5 is 40. Carry the 4. 8 times 0 is
0.
0, but plus 4 will make it 4. And finally, 8 times 7 is 56. Write that here. Add everything up. 5 plus 0 is 5. 3 plus 0 is 3. 9 plus 4 is 13. Carry the 1. 6 plus 4 is 10. Plus 1 is 11. Carry the 1. And 5 plus 1 is 6. As you can see, you'll get a lot of practice with addition and from lecture 2, doing these larger multiplication problems. Now, I just want to point out, what would we do if we had 3 digits in the bottom row? If we had a 3-digit number times a 3-digit number. When we got to the hundreds place in the bottom row, or the working row, instead of adding 1 0, I'd add 2 zeros, because now I would be multiplying by some number of hundreds, right? So I would need to make sure that I had 2 zeros behind whatever product that I got, okay? Oh, actually, that's what I was going to do next. I was going to do a 3-digit example. So I kind of got ahead of myself there. All right, the final problem that I want to work is a 3-digit by 3-digit problem. This is a 3 by 3. And we're going to do 421 times 315. So it's no harder than before, it's just more steps, okay? And if we write very neatly, we should minimize any errors that we make, and hopefully we won't make any errors. But we'll start with the 5. 5 times 1 is 5. 5 times 2 is 10. We'll write the 0 from 10 down here in the answer section and carry the 1 up to the next digit. 5 times 4 is 20, plus 1 makes 21. Strike through the carry that I've already used. Move on to the next digit, the 1. 1 times 1, oh, I forgot to write the 0. 1 times 1 is 1. 1 times 2 is 2. And 1 times 4 is 4. And luckily I struck out that carry, otherwise I might have accidentally added it and written a 5. Now for the next row, because it's 300s, we need to write 2 zeros. Or again, you can just use the rule that your answer is going to begin in, directly beneath the working digit. So beneath the 3 in this case. And everything to the right should be zeros. So 3 times 1 is 3. 3 times 2 is 6. and 3 times 4 is 12. And so now that I have all of my separate products, remember this is 421 times 5, that's what's in this row. And in the middle row we have 421 times 1. And in the bottom row we have 421 times 3.
Oh no, not again. That should read 421 times 5, 421 times 10, and 421 times 300.
So we need to add all those parts up. Now we haven't done any addition of 3 rows before, so I'll give you a little bit of a helpful strategy. And in the homework, I'll put a few problems where you add 3 or 4 rows of numbers up. But a good strategy to employ here is to try to find tens. Okay. Now the first couple of columns that we have to deal with are pretty easy because 5 plus 0 plus 0 is just 5. 0 plus 1 plus 0, well, that's just 1. Here in the next column, we have 3 plus 2 is 5, plus 1 more is 6. Now maybe you would have preferred to do 3 plus 1 is 4 and then add 2, which is also 6. It doesn't matter, whatever is easier for you. But in the next column, a good strategy to employ, don't do 6 plus 2 is 8 and then add 4. Notice that 6 and 4, right, 4 is the tens complement of 6, and 6 is the tens complement of 4. When you see tens complements in there as pairs, those count for 10, right? So you look at these two numbers, 6 and 4 is 10, and then 10 plus 2 is just 12. So write down the 2, carry the 1, 2 plus 1 is 3, and 1, there's nothing else there, so we just write 1, and we get our final answer, 132,615. It's a pretty big number, huh? We will encounter large numbers like this fairly frequently, especially when we start multiplying decimals, because though these are really large numbers and their products are even bigger, oftentimes when working with smaller numbers that have decimal points, you still have a lot of digits that you have to multiply, and so you'll end up doing problems that look very similar to this, even though the scale, the magnitude of the numbers are small, like 4.21 times 3.15, but we would basically set it up exactly the same way. But we'll get to that when we talk about decimal numbers. We've gone over how to do long form or paper multiplication of 2 by 1 numbers, 2 by 2 numbers, and 3 by 2 and 3 by 3 numbers. Next time, we'll learn to do long division. I'll see you then. Okay.